What if you need to find every email address in a document, extract all phone numbers from customer records, or remove every URL from scraped text? Writing code to do that manually is painful. Regular expressions let you describe a pattern once and find every match instantly. In this episode, we go line by line through the regex tools you will use constantly in NLP. A regular expression is a sequence of characters that defines a search pattern. Instead of searching for a fixed string, you describe what the text should look like. For example, a pattern that means one or more digits or a word that starts with a capital letter. Python provides the RE module for working with regular expressions. It can find matches, extract them, replace them, or split text on them. You will use regex in almost every NLP pre-processing pipeline you ever build. Before writing any regex, you need to know the core special characters. A dot matches any single character. \D matches any digit. \W matches any word character including letters, digits, and underscores. \S matches any white space. The plus sign means one or more of the previous pattern. The asterisk means 0 or more. The question mark means 0 or 1. The caret anchors to the start of a string and the $sign anchors to the end. Square brackets define a character class. The pipe symbol means or, and the parentheses create a capturing group. The RE module provides several functions. The search function scans the entire string and returns the first location where the pattern matches. Here, we search for one or more digits using \D+ and find 42. The group method on the result returns the actual match text. The match function only checks at the very start of the string. Since our string does not start with a digit, match returns none. Match only succeeds when the pattern fits at position 0. The findAll function returns a list of every match in the string. Here, we first find all digit sequences, which returns each group of digits separately. Then, we use a more specific pattern. \D with curly brace 3 matches exactly 3 digits, followed by a dash, followed by 3 more digits, a dash, and 4 digits. This pattern precisely matches complete phone numbers and returns both of them. Curly braces let you specify an exact count for how many times a pattern must repeat. The sub function replaces every match with a replacement string. Here, we use it to remove URLs. The pattern https:// // plus matches both HTTP and HTTPS URLs followed by any non-white space characters. Replacing with an empty string removes them. We then clean up the leftover extra spaces with a second substitution. In the second example, we replace all numbers with the placeholder token num. This is a common normalization technique that helps models focus on word patterns rather than specific numeric values. Capturing groups let you extract specific parts of a match. Wrap any part of your pattern in parentheses to create a group. Here, we match an email address and split it into 2 groups, the username before the @ symbol and the domain after it. Group 0 always returns the full match. Group 1 returns the first set of parentheses, and Group 2 returns the second. This is extremely useful when you need to extract structured information from unstructured text. Here are 3 of the most common regex tasks in NLP. Extracting email addresses using a pattern that matches word characters and dots before and after the @ symbol. Extracting hashtags using the hash symbol followed by one or more word characters. And extracting phone numbers using the 3-digit dash, 3-digit dash, 4-digit pattern. All 3 run on the same string in just a few lines. These patterns appear in almost every real-world text processing pipeline. When you need to apply the same pattern to many strings, compile it first using re.compile. This translates the pattern into an internal representation once and reuses it on every call, which is significantly faster than recompiling on every search. The compiled pattern object has all the same methods: findAll, search, sub, and match. You can also pass flags when compiling. The re.ignore case flag makes the pattern match regardless of whether letters are uppercase or lowercase. You now know how to use regular expressions in Python for NLP. Finding patterns with search and match, extracting all matches with find all, replacing and cleaning text with sub, using capturing groups to extract specific parts, and compiling patterns for performance. In the next episode, we cover bag of words, the first text representation technique that converts text into numbers a model can actually learn from. If this helped you, subscribe so you do not miss the rest of the series.